Hey guys, just doing a quick video on the measurement DI for year 10, just a little guide for part 1 to get you started on this assignment. So the first step, I'm doing part 1, the first step of part 1 is to choose a single solid with your own dimensions and you find its surface area, SA and volume V. So that's how I'm going to refer to surface area and volume for the rest of this video. SA and V. So I'm going to choose a cube that's 2 centimeters by 2 centimeters. You're not allowed to use that, and I'll know because I'm marking your work. This is an example for you to copy off of. But for your DI, you need to choose your own shape, okay? So it's 2 centimeter by 2 centimeter cube. So the surface area is going to be 2 by 2, which is one of the sides. And there's 6 sides times by 6. So that's going to be 2 times 2, 4, times by 6, 24. 24 square centimeters. The volume is going to be 2 times 2 times 2, which is going to be 8 cubic centimeters. All right? And now we're going to go into it later, but right now, to save me some time, I'm going to find the surface area to volume ratio, which is what this DI is all about. Is a comparison between the surface area and volume of an object. Surface area to volume ratio can be expressed as a fraction, surface area over volume. So it's going to be 24 over 8, which is 3. So I'm going to put an underline under the 3 important numbers that I found there. All right. Part B, find the surface area and the volume of the solid from part A, but with its dimensions doubled, i.e. at a scale factor of 2. So I'm doubling the size of this thing by doubling the dimensions. That's the same as saying it has a scale factor of 2. So I've got another cube, but instead of 2 by 2 by 2, I'm doubling the dimensions, so it's going to be 4 by 4 centimeters. Okay, so the surface area is going to be 4 times by 4 times by 6. 4 times 4 times 6 is 96 square centimeters. The volume is going to be 4 times 4 times 4. 4 times 4 times 4, 64 cubic centimeters. So the surface area to volume ratio is going to be 96 on 64. That's going to be 1.5. So that's A and B done. C, make a prediction about how the surface area to volume ratio will change as you increase the scale factor. So this is a prediction. You don't have to be right about this. You just have to make a guess as to what you think is going to happen, because your maths will prove whether you're right or you're wrong. So we've established a trend. Not for a long time, we've only got 2 examples, but I noticed something here. It's halved. So maybe my prediction could be surface area to volume ratio will halve every time scale factor increases by 1. That could be a prediction, or I could just be more simple and just say it's going to lose 1.5 every time. So the next one would be 0. I don't know. We don't have to be right about that. Decrease by 1.5 every time scale factor increases by 1. We don't know. You just have to make a statement before you actually do the maths. Okay, so those are a couple of examples of predictions. You need to write your own for your assignment. Okay? Apply the next 6 scale factors up to 8 to your solid. Find the surface area to volume ratio at each scale factor. I'm only going to show up to scale factor 4 because this is a help video. I'm not doing your assignment for you. So scale factor 3... all the dimensions going to be times by 3, so it's going to be, it was originally 2 by 2 by 2, now it's going to be 6 by 6. So the surface area is going to be 6 times 6 times by 6. Because there's 6 sides. 216 square centimeters. The volume is going to be 6 times 6 times 6 again, because it's length times width times height. So it's going to be 216 cubic centimeters. So the surface area to volume ratio is easy. It's going to be 216 over 216, which is going to be 1. Scale factor 4 is going to be 4 times by 2. So all the sides are going to be 8 centimeters. So the surface area is going to be 8 times 8 times 6. 8 times 8 times 6. 384 square centimeters. The volume is going to be 8 times 8 times 8. 512 cubic centimeters. So this is the first one where the volume has been larger than the surface area. So it's going to be a ratio that's less than 1. 384 over 512. 0.75. So I've done down to scale factor 4. I'm not going to continue the rest because you need to do the rest yourself. So what we do next in part E, once you've done all the scale factors, you fill in the following table. So I've done the scale factors from 1 to 2, 3 to 4. You're going to do down to 8. I'm going to fill in the surface areas. So they were 2496, 2496, 216, 384. The volumes were 864, 864, 216, 512. The surface area to volume ratios were 3, 1.5, 1, 0.75. So my prediction was proven both wrong. It halved here, but that's not half of 1.5, and this isn't half of 1, so it hasn't been halving. It also hasn't been losing 1.5 each time, so I'll mention that in the analysis. Change in SAV from previous. So the point of me showing this is to show you how to fill in these last two. The change in SAV is going to be the change in this number from the previous. But there was no previous to scale factor 1, so this is going to be a dash. This column is asking percentage change in SAV from previous. Because there was no previous, that's also going to be a dash. There is no previous to the first one. But this one has had a change. It went from 3 to 1.5. So if you want to find the change, you go the new minus the old is equal to the change, negative 1.5. Now the percentage change, if you want to express anything as a percentage, it's the number of interest over the original number, and then you times that by 100%. So the number of interest is the change, because I'm finding percentage change in SAV from the previous, so the original number was 3. So it's going to be 1.5 over 3 times by 100%. So it's going to be negative 50%. We'll do the same thing here. So it's the new number minus what it was before. 1 minus 1.5 is going to be negative 0.5 to find the percentage. Negative 0.5 over the previous number, which was 1.5, times by 100%. On the calculator, negative 0.5 divided by 1.5 times 100, negative 33.33%. That's to 2 decimal points. Running out of space here, sorry about that. There must be a better way to write that. I'll go equals and then go negative 33.33%. down there to 2 decimal points. I'll put underlines there just to make it obvious what the answer is. This one, 0.75 minus 1 is negative 0.25. So it's negative 0.25 over 1 times by 100%. I can see that is negative 25%. No rounding. Okay? So that is the scale factors from 1 to 4 done for my chosen. You guys need to do all the way down to scale factor 8. Continue the table to scale factor 8. That's up to you with your solid. And so what do we do now? We've got 2 more steps of part 1. F, draw a graph of the scale factor versus surface area to volume ratio. So the scale factors were 1 to 8. I only did up to 4. The surface area to volume ratios were 3, 1.5. So scale factor 1, the surface area to volume ratio was... This has moved. Sorry about that. The graph had moved. Now it's on the dots now. You can see there. So scale factor 1, it was at a surface area to volume ratio of 3. Where did I get that from? Scale factor 1, surface area to volume ratio of 3. So now it's 2 and 1.5. So I need to place that dot. 2 and 1.5 is in the middle there. We can see at the top of the page 3 and 1. And 4 and 0.75. So half is there. So you can see it's forming a line that started off steep, but it's flattening out. So what is that saying about the data? Remember that surface area to volume ratio is comparing the amount of surface area it has to the volume. So it's telling you how much surface area for the given volume that you've got. So the first one, the small cube, had a high amount of surface area compared to its volume. This one had slightly smaller. This one had an equal amount of surface area to volume ratio. When you got to 4 times the size of the original, it's actually got less surface area than its volume. That's why it's got a fractional ratio here. So what you're seeing is, as you get larger, the amount of surface area you have compared to your volume is dipping down, 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 but it dips fast when you're small, and then it's slowly flattening out as you get bigger and bigger. So that's got relevant ramifications for your DI. And because I'm showing you this, I'm not going to go into the analysis of it. You're supposed to bring it back into the context. I've given you plenty already by talking about the shape of that. You just need to bring it back into the context of the baby suffering from hyperthermia. Now part 2, finishing up here, you're going to repeat the above steps B to G except for step C, but with your design for the baby shape made of 3D objects. So you're going to design something that vaguely looks like a baby out of 3D shapes, like 6 parts or something. And then you're going to do this same process. You're going to find the surface area, the volume, find the surface area to volume ratio. Surface area to volume at the next scale factor up, find the surface area to volume ratio. Fill in the table, and you're going to try to see if you have the same shaped graph. If it's not the same shaped graph, you've done something wrong. I'll tell you that right now. All right, so that is the video on helping you or guiding you with the measurement DI for Year 10 Maths. Hopefully that helps you out. And I'll see you in the next video.